Hello and welcome to the fourth video of our calculus series. In the previous videos, we've been using the limit definition of a derivative to derive, which can take quite some time. But fortunately for us, there are quite a few shortcuts you can take to make the whole process shorter. So the first one we're going to discuss about is the power rule. Say you have a function f of x that's equal to a times x to the nth power. And a is some real number and n is some real number. Now I'm going to throw some notation at you. D over dx of a times x to the nth power. Now what this represents is whatever is inside the parentheses, we're just finding the derivative of. And this x just means we're deriving based on x. And now this is equal to a times n, so the coefficient times the exponent, times x to the n minus 1 power, so the exponent subtracted by 1. Now this is basically the power rule, and this is equal to f prime of x, which is a way we write a derivative. And in another notation, we can also write dy over dx. Now let's look at an example. Say you have f of x equal to 4x squared. F prime of x would simply be 8x. You're multiplying the exponent by the coefficient, so that's 8. You subtract 2 by 1, it's 1. Now you can find the derivative at a specific x value as well. Say you wanted to find f prime of 3, you would just have to plug in 3 into 8x and you would get 24. And that's what the power rule is basically. Now let's move on to the sum and difference. So this works for both addition and subtraction. So you can just distribute the d over dx to each function and derive them separately. Like that. So say we want to see an example. F of x equals 3x cubed plus 4x plus 1. F prime of x would simply be 9x squared plus 4 plus 0. Now you see that x has an exponent of 1, so 1 minus 1 is 0. X to the 0th power is just 1, so we just bring down the 4. And 1 is a constant, so it has a derivative of 0. And if you were on a graph, it would look like that. And we know that this line has a slope of 0. And that's what sum slash difference rule is. Now let's move on to the product and quotient rule. So say you had d over dx of f of x times g of x. That's equal to f prime of x times g of x plus f of x times g prime of x. Now, all this really means is that we're taking the derivative of the first function, multiplying it by the second function, and then in the second term, we're doing the reverse. We're leaving f of x how it is, and we're finding the derivative of g of x instead, the second function. And now let's look at an example. Let's say h of x equals 3x squared plus 2x times 5x cubed minus 4. H prime of x would be 6x plus 2 times 5x cubed minus 4 plus 3x squared plus 2x times 15x squared. And that's what the product rule is. Now let's talk about the quotient rule. So say you had a function h of x equal to f of x over g of x. H prime of x would equal f prime of x, so the derivative of the numerator, times g of x, the denominator, minus g prime of x, the denominator, times f of x, the numerator, divided by g of x squared. And let's look at an example. So this would equal 12x cubed minus 8x squared. And what we did there is we just found the derivative of the numerator. So this would represent f of x. And then we're just going to multiply by the denominator. For what it is, we're not deriving it. Subtracted by 10x plus 3, which is the denominator. So we're deriving g of x times 3x to the fourth minus 2x cubed. So we're keeping f of x the same. And the denominator would just be 5x squared plus 3x squared. And that's how you use the quotient rule. Let's move on to the chain rule now, which is going to be the last shortcut we're going to learn today. Say you have d over dx of f of g of x. So what the chain rule is that it deals with the composition of functions. And this would be equal to f prime of g of x times g prime of x. So the way we need to look at this is in layers. First, you're going to be looking at the outer function. You're going to derive that, and you're going to leave all the inner function or functions. There are going to be multiple inner functions, but in this case there's just g of x. We're going to leave those functions alone. So you see that in the first factor, g of x is untouched. And then once you're done with the outer function, you're going to multiply that by the derivative of the inner function. So this would be g of x right here, and you just you find the derivative of that, which is g prime of x, and you multiply it by the first factor. So let's look at an example. Say we have d over dx of 3x plus 4 cubed. Now we're going to imagine that 3x plus 4 isn't there. We're focusing on the outer function, which is the exponent. So look at it like this. Imagine there's a blank. We're going to multiply 3 by the coefficient, which is 1 right here. So the coefficient would just be 3. And then you would subtract the exponent by 1. You would get 2. Now you just leave the function alone, 3x plus 4, and now you're done with the first factor. Then you're going to multiply it by the derivative of 3x plus 4. So then that would just be 3. And this is just a simple example. There can be multiple layers. And that's it for this video. Please like, comment, and subscribe. Hope to see you in the next one.